Once again, this is our y equals the tangent x functions. As you may notice, the vertical asymptotes happened at negative pi over 2 to pi over 2, right? And as you may notice, this particular curve in here just keeps on repeating itself, then that will be equivalent to our 1 period. Get it? So again, 1 period is from negative pi over 2 to pi over 2. Those are our two vertical asymptotes, and it will continue moving by that much units. Are we good, guys? And then, with that being said, these are our rules for tangent once again. The stretch factor, A, is the one that's multiplied in front of the tangent function, okay? So once again, as your A moves more positive like 2, 3, or 4, then it stretches vertically some more, right? It can compress as well once your A is what? Less than 1 but positive, like 1/2, 1/4, so that's a vertical compression. Okay? Once again, if that's a negative, then it's just gonna flip along the x-axis or horizontally as well, right? So it can flip as well, and with that being said, that's what we call horizontal reflection, all right? Some cases, x-axis reflection. Once again, the period in here, unlike the sine and cosine, is pi units, right? So pi over 2, well, negative pi over 2 to pi over 2. So with that being said, if you are given the period, then b, that multiplier for x, is pi over b instead of 2 pi over the period, okay? The c will determine how much we're gonna move to the right or to the left from the origin or the y-axis. So if you move to the left, then your c is positive. Where's the left? Left, positive, okay? Right, it's negative. Get it? And that d is our vertical shift. So as you may notice in here, we may not be using the word midline anymore because that basically is typically for sine and cosine function. We can still call it as midline because honestly, that vertical shift in there, if you cut along that horizontal line, that still cuts it up and down midway, right? But again, it doesn't apply for secant and cosecant anymore. So in here, whether you call it midline or vertical shift, as long as if it's plus, then you move up, bless you. As you go down, then it's minus. Good. And the vertical asymptote, we're going to talk about that one later, but the basis for that one will be the pi over 2 and multiples of the c, or the horizontal shift, how much we are moving. Are we good, guys? Now, let us answer some cases for this functioning here. So we got this one, real world application number 54. So let's read this one and analyze the key features of this tangent function as well, okay? Krish, let's go ahead and read this 54. Thank you.
The function f of x equals 20 tangent pi over 10x marks the distance of the orbit of a light beam of a police car across a wall for time x in seconds and distance at the venue.
Thank you. Now, let's graph this one on the interval from 0 to 5, okay? Next, let's find and interpret the stretching factor, period, and asymptotes. And lastly, let's evaluate what? F1 and F2.5 and discuss the function's value at those inputs, right? So let's discuss this one first, okay? So according to this graph, this is again of the form of y is equal to what? A, right? Tangent b x plus c plus b, right? Now with that being said, our A is what? 20, right? Okay. Our B is the multiplier of x, which is pi over 10. So this is pi over 10. Okay. Our C and D in here turn out to be what? Oh, well, again, this is B, right? And our C and D turn out to be 0, right? So with that being said, There's no horizontal shift, right? It didn't move right or left. It also didn't move up nor down. Be good? However, there's a vertical stretch because that's positive 20, more than 1. And there's also a b pi over 10, right? Now with that being said, we can already answer. What's the stretch factor? 20. Very good, right? So stretch factor is 20. So we know that it's a vertical stretch. Get it? Vertical stretch. Next, what is the period? So once again, we're going to use our triangle for the period. So if you can recall our triangle a while ago, pi on top, right? Because one period for tangent is pi, and this is what? B over, B and P, right? So in short, to get the period, how do we get the period in there? Yes, yes, yes. So we encircle this to get P, pi over B. Get it? So that's it. Period is equal to, according to this one, is pi over B. So that's equal to pi over B, which is pi over 10, right? So with that being said, these pi's will cancel out. Hence, what's your period? 10. That's the length, horizontal length of one cycle. Get it? Okay. Good. Well, let's see. How does it look like now? Let's see. How does it look like? And then after that, we can analyze. So once again, this is our tangent of x with asymptotes at negative pi over 2 to pi over 2, right? However, for this one, we got what? Y is equal to 20, right? Tangent, what did we say again? Pi over 10 x. Are we good, guys? Right. Pi over 10x. So how does it look like? So we're gonna x this out first, the typical tangent of x, and see it in here. Are we good? So in here we said we're gonna analyze it from, it says a while ago, 0 to 5, right? Okay. So if we analyze it from 0 to 5, oops, I forgot to make the steps by ones as well, right? Again, 0 to 5. Did it say seconds or minutes? Seconds. So that's 0 to 5 seconds. And what do we notice in here?
We can't see.
Oh, sorry for that. Okay, there we go. So as you may notice in here, from 0 to 5, good? Okay. You know what? Let me cut it out in there, right? So 0 less than or equal to x less than or equal to 5, right? It says 0 to 5 seconds, right? Okay. And then what do we notice in here? What's happening to the distance? As x goes from where? Goes from 0 to 5. Your y goes from where to where? From 0 to where?
Infinity.
Infinity. Very good, right? So as we may notice in here, 5 is already our, what we call vertical asymptotes. Are we good? So with that being said, what's the vertical asymptote in here? X is equal to 5, as you may notice in there, right? Where else? X is equal to 0. Well, it actually hits this one, right? But what do you think is this one in here?
Oh, -5?
Negative 5. Right, there you go. Are we good? All right. And so on. Right? So there we go. Our vertical asymptotes in here happened at what? 5. Well, by the way, since we're talking about time, then we cannot consider that -5 anymore, right? We're just considering positive values, right? So in short, after 5, what's next? Plus 10, right? Which is what? X is equal to what? 15, right? What's next? 25, right? And so on, right? So X is equal to 25. And so on. Are we good, guys? All right. So there we go as our analysis for such. Let me go ahead and X this out. So as you may notice in here, from 0 to 5 of X, right? Your distance goes from 0 to what? Infinity, right? There we go. And as you may notice in here, the vertical asymptotes happen at where? At 5 seconds, right? And then after that, after 15 seconds, after 25 seconds, and so on. Get it, guys? Okay. However, I would also notice in here that technically for this one, we just consider the domain as just from 0 to 5 seconds. Okay? Because honestly, the distance cannot be negative as well, right? So with that being said, we cannot consider these negatives for such, right? So with that being said, trying to analyze this one in here. First of all, so we graph the interval from 0 to 5 and we notice that your distance, okay, in here translates from where? From 0 to infinity. Good. Find and interpret the stretching factor. So the stretching factor is again, how much? 20, right? The period is how much? Once again, we said a while ago. 10, right? As you. And the asymptote will be at what? At x is equal to 5 seconds. Good. Right? Last one. Evaluate f of 1. So what's f of 1 in here? And f of 2.5. So going back to the graph, here it is. See how it is now, right? What does it say? X equals 1, right? X equals 1. Right? So what did it say in there? Okay, so what can you say about that? And the other one, x is equal to what? 2.5. It says 2.5, right? Okay, like midway between 0 and 5 seconds. All right, so what did we notice in there? After 1 second, it's how much? Almost 6.5. Did it say meters or feet? Feet, right? Yeah. And at 2.5 or halfway between 0 and 5 seconds, at 2.5 seconds, it's how much? 20. And what's the significance of the 20, guys? What's the significance of the 20? Is it the what? Is the stretch factor as well, right? As you may notice in here, that 20 is in fact the what's this? The stretch factor. That's what we mentioned a while ago, right? Ano to? Or what we call the stretch factor. Good, guys. So summarizing that one, so here it is now. As we may notice, the A, or the multiplier of tangent, is your stretch factor. It can also flip horizontally if it's negative. The B will tell us what the period is by multiplying what? Or dividing pi over the B, right? The horizontal shift is that C, right? Depending on if it goes left, positive, or right, negative. That also will be our consideration for the vertical asymptote. And last one, we can call it vertical shift or midline, right? That's the one that moves it up or down for both the tangent and the cotangent function, right? And as you may notice on the cotangent function, it typically is similar to tangent. It's just flipped and pushed aside from 0 to pi instead. How we good, guys?